Thank you for joining us for this Vulcan webinar. My name is Steve Sullivan and I'm a technical specialist based in Maptek's Adelaide office. As you know, Vulcan provides a comprehensive suite of tools for resource geology, so not even the most experienced users can be expected to know them all. In part one of our series on rediscovering the power of Vulcan for geology, we outlined how to integrate a broad range of different data when building your geological models. Today, Technical Solutions Specialist Lance Steele and I will showcase some overlooked functionality that will assist your resource modelling. Topics to be included in the next 20 minutes are shown on the slide. If you have any questions during the webinar, please enter them into the questions panel on the GoToWebinar interface, and we'll answer them at the end of the session. And now I invite Lance Steele to introduce himself and start his presentation.
Thanks, Steve. Hi, everyone. My name is Lance Steele, and I'm a geologist based out of the Maptek Adelaide office. Today, I'm going to chat about some of the applications that Vulcan has had for many years, as well as some new and improved alternatives to existing functionality in Vulcan. So to start off, I'd like to show off the ability of how users can import registered images such as ECW files and WMS files, which can be useful for exploration projects. Applications include a range of geophysical data, and I'll take a look at the ECW file import first. So what you can see on my screen at the moment is an example of a ECW file that's been imported. But what I'm going to do is just show you how to import one. And the way to do that is to go to the model menu up at the top here, go to image registration, and then import georeferenced image. Basically, a window pops up, and as you can see from this drop-down menu, you've got a number of options. In this case, I'm going to select the ECW file and go to Browse. Select the ECW genetic file called a TMI, and what I'm going to do is you just give it a IREG file name and a triangulation file name, pretty standard in Vulcan, and you select OK. Now it's just going to ask you if you want to do it in meters, and you say OK. What I'm going to do is just show you how to make one of the images translucent, and then if I right click on this button over here, I can adjust the translucency of those images. I can bring them back and forth like that. In addition to that, we can add the WMS import. And what users can do is go to the same functionality here, image registration, to import georeference images, but I'll focus on the WMS this time. Go to Setup and Data. In this case, on physics. Now, basically what happens is a WMS map window, secondary window opens up, and you've got a number of options here. So basically, I'm going to select a grayscale TMI, and you've got a number of options in terms of your coordinate system. I'm just going to choose the CRS. In this case, again, it's a TMI, so I'm just going to call it TMI 1. Type in 1, 1, and 1, and select OK. And you can view one or two overlaid onto each other, which is quite nice. Now, some of the advantages of being able to import these images is being able to overlay this sort of images over sort of brownfield drill holes, as well as surfaces, down the hole LAS data, or even televiewer data. And also with this WMS data, users can access a wide range of data that is usually open source, particularly here in Australia. Now, what I'll do is I'll just remove that. Moving on to the sample data, I'll now focus on highlighting some of the improved alternatives to viewing composite data. Viewing sample data is particularly important to display, so then users can confirm if the data is representative of what they're after. I'll now show you how to display composites using Composite Display Tool, followed by the Samples Display Tool. Being able to display composites in the past, you can select Composites and you can select Display. You can specify as points or lines and give it a size, let's say 4, and say OK. Select your composites database and you say OK. Give it the value of gold, for example. You can specify label the lines as well as load the geology only, say finish, and select your legend. Now, if I just refresh the view there, if I hit the fast key C for center of rotation and click there, you can see the data visible. Something that's available in Vulcan 12, which has recently been released, is under the user databases, you can actually drag and drop into the view from the user databases directly. And again, I'll just select gold, specify your SCD file, in this case AU, and OK. There's the two options of being able to import your composites. Something that's more recent is being able to display your data sampling tool. So first off, you need to open up the database. In this case, I'm going to select the composite again, and then again go back to geology and select your sampling, and then go to load. Now the key thing here is to make sure this is unticked, to select as all, and you say, okay, to go specify whether you want points or lines. But something that's better with the samples option is being able to display shapes. So for example, you can specify a constant shape, or you can specify the size of the field, let's say AU, and in this case, I'm going to specify a size of 1.05. Inside your field, you just need to select in each line item AU, in this case, and then also the shape legend. And then from there, specify your restrict samples to be displayed. Now, what will happen is this window will open up. And what's quite nice, this is in theory like a filter system. So you select, for example, like a numeric tag. Again, I'm going to select gold. I'm going to specify by range. You can also specify by, say, for example, lithology. I'll just leave that unticked for now. And then select using solid triangulations. Once done, you select OK, brings up your filter. So I'll say 10 to about 60, just as an example. Say next. You've got to add a triangulation, go to ore body, drag that across and say OK. Select OK again. In addition, you're also able to display your gold value. And you can specify where that gold value, the text is actually sitting next to your point, which is shown in 3D. So that's pretty customizable. And then from there, you select OK. And what you can see is the actual data. The grades are filtered by 10 to 60. And you can see the scale here is much larger relative to the rest of the deposit. If I load up the ore body, you can actually see in 3D. Some of the advantages with this is being able to identify areas with, say, like high grade through displaying shapes and displaying values, as well as scaling by the size and shape. So this is really good for sort of grade control. And in addition, you also have more control on what is being displayed using a wide range of filters, as I've just shown you. Now, moving on, what I'm just going to do is remove the samples and then just load up my drill holes. Now, what I'm going to do is analyze some swath plots. And what this will do is I will focus on the actual analysis of samples. So basically, swath plots are useful for identifying trends and understanding how the grade changes along a particular vector. Considering multiple swath plots along different vectors can indicate directions of continuity/variability. In addition, geologists are able to identify trends between, say, your samples database and a block model. So to start off, I'll now show you the original way using a database drift analyzer. So if I go into the geology menu, again into sampling, and you select a database drift analyzer. In this case, I've got a spec file set up already. It will just load up all the preconditions. And if I go through those, you can actually see that I've specified by a certain lith, by a certain triangulation, that triangulation being the yellow box on the right there. And then you select your lithology and your output options, and you simply save and run. What I've got is the actual Excel spreadsheet available. So there's your Y drift, your Z drift, and your X drift. So that's quite nice. But what I'll do now is actually show you Vulcan Data Analyzer, or VDA. What I'm going to show you now is the swath plot analysis. And basically, if I go into, with this VDA, I can open up the data source. The block model first I need to do is select the block model, because it's going to be a filter designed for the block model. Select block. And what I'm going to do is just select block block model underneath by the ore body only. Now, what I'm going to type out now is something that users can find under the functions and operators. If they just search for it up in the help menu up at the top right. And for example, here, I just want to type in AU_IVD, which is one of the variables that is available in my block model, is greater than 0. If it's not happy with it, it will highlight it as red. But once that sort of information is clear, then you're okay to move on to the next section. In this case, I'm going to select again by the yellow bounding section and then say OK. Now, what will happen is you've got this drop down over here. Because it's a block model, I'll go to my block model gold inverse distance and I select apply filter. What it's created is a additional attribute, but with the filter selected. Now, what I want to do is create an additional filter, this time for the samples. AU, and select a numeric filter. This case, it's going to be gold, and I'm going to specify 0 up to a greater value. And this is to filter any -99 or -1 values that sometimes occur in databases. Select the character field, in this case, geocode by SP, and then select the triangulation. In this case, it's going to be 1006, same yellow one in the view, and select OK. Now what I'll do is select the AU from the composite database. As you can see, there's 2 there now, and I just make sure I've got my samples, make sure I've got my right variable underneath the composite, and I select apply filter. Now what I've got these 2, and I hold down Control to select both of them. Simply go to the stats menu now, and you can choose a number of these charts. In this case, I'm going to do the Swath plots. And on the right-hand side, you can choose your spacing. Just so then I can compare apples with apples, I'm going to select 10, 10, 10, the same as the previous option with the database drift analyzer. And then I simply select the green arrow, green tick. And at the bottom left, you'll see it will be generating the plot. Now, what you can see in the view here is the X, Y, and Z direction. So, for example, if I go to the bottom left here, I can select the X or the Y direction, which is quite nice. Now, what I'll do is I'll just sort of compare that so users can actually see and focus on the Y drift. And what you'll notice there, they are fairly similar. So I'll just close that off. And what you can do with these and recalculate or cancel if you're going from one to the other, and then update the chart as you go along. Now, some advantages of the VDA. The VDA is way faster. It'll take you several minutes to push out one sort of Excel spreadsheet, whereas this one is fairly dynamic, as you've just seen. You can calculate a number of classes as well. It's very, very dynamic in being able to change back and forth between different variables. And what's also quite nice is you can apply as many filters as you want. And what's really great about this is you can actually save what you've done. So this is quite nice from an auditing point of view. So I'll just go to File, Save As, and select VDA as an example and say OK. Now that will save in your Vulcan project. What's also nice is the visual improvements. Something that's quite nice, you can export these out as a PNG image or export the data out as a CSV. And what's also quite nice is you can actually do this on a number of data sets. So for example, you can run it on a number of block model files. For example, you can run it on different estimation techniques or whatever the case may be. Composites, different run lengths, 1 meter, 2 meter, half meter, whatever the case may be. So you can compare apples with apples and run everything accordingly. So that's quite nice. In addition, once you've done with this, you can just close up that. When you open up the VDA project, you come back to the chart, which is found down at the bottom left here, and you double click on that, and there's your project. Go back to the data, it's all there. So that's quite nice. So that concludes my topics for today. Please remember to type in any questions that you may have in this question section. Over to you, Steve.
Thanks, Lance. And while we just change over the screens to my screen and a different data set, I travel around to a lot of different sites around the world and often surprised about some of the functionality that Vulcan's had for many decades that some people aren't aware of. So what I'll do is I'll continue on from a couple of items in that category under the geology sampling menu. So you can see in front of you here a series of drill holes from a deposit. I've got a grid there, so you've got about a kilometre by a kilometre space grid, so you can put that in context from there. Just to remove that grid, just rotate that data around just to give you a brief look at it. So we have here the ore body. The area of interest is in red and yellow down here, and the overburden there in more green colour with the footwall underneath in grey. So declustering is a technique for making the samples you take into your estimation more representative. So you can see there from the distribution of data, we've got some quite widely spaced holes, some quite regular pattern drilled, and then some more intensely drilled areas here. Some of them are vertical, some of them are on angle. So it ends up with quite not random, but quite an unequal sample distribution. A fairly simple setup. Again, you tap into your database, in this case a composite database. You select the variable you want to work with, in this case it's zinc. And I've got a spare field in my database, an empty field, which I'm writing the declustering weights from this process. Again, the standard ways of selecting data through numerics, characters, solids, etc., so that you can subset and get the samples that you want into the analysis. Here comes the declustering parameters themselves. You've got a range of different cell sizes that you want to look at, to review, to see what is a representative sample for your data. So I'm going to go through here to the chart, and you can see here a chart where the highest value, or highest average value based on all the data is about over 16% zinc. If I look at here and I'm going for a minimum weighted average grade in the declustering, I come down to 12.65. What we're doing is trying to make that a minimum, so I can vary the chart parameters, refresh that. You can see there that hardly made any difference. Put that back to this one, and you can modify these and get to a dynamic update on that chart. So you can see that's moved that a little further apart, and say we've got, say, 150 metre type cell size to get a representative sampling here. So you can use those settings. Once you're happy with the settings, you can apply and run that. That then goes and writes that into that declust field into your database. Now, what impact does that have on your grade estimation? Well, let's have a look again. Data Analyzer, Lance has given you a nice little introduction to that. I'll open one that I've already done, decluster. And here is for this data. You can here have a look. First of all, in the dark blue is the raw composite data, and in the light blue underneath you have these declustered values. So you can see in every direction, X, Y, and Z, that there is a variation between the two. In most cases, you should find that the raw data is slightly higher than, in some cases, a little bit higher than the declustered, depending on the sample distribution. So the combination there of the decluster menu and then the new Swath plot in VDA, just to show you that it has done some process. Okay, the next thing we're going to look at is the contact profile analyzer, and I'll go into section view here. We've got a cross section going through the data here. Just click on that line. And what you'll see again is a distribution of drill holes there, and I've just highlighted and labelled two. So the ore body is generally this red shape, and you can see here it's called LMS. Over the top we have a horizon, underneath we have a footwall horizon. And what we want to do is have a look using the contact profile analyzer to see, is the grade across this contact in the hanging wall and in the footwall, is it a gradational contact or is it a very sharp contact? So to do this, and this functionality is in the sampling menu for contact profile analyzer. And again, it's been there for many, many versions. Similar to what many other panels of Vulcan are, we can have a look, first of all, at the hanging wall. We have the specification file we can rerun. We're looking at a search distance of 20 metres away from the contact in 1 metre steps either direction. We connect up the database, the composite database here with, this case, I've got the ore body and the same thing, it's the same database, and this time I've got the hanging wall unit. Again, I'm writing it out to Excel, got some settings there, and I can run that. It does some analysis every metre away from that, and it gives some charts. and in my folder here, generated an Excel spreadsheet, which I'll then bring over to the screen for you. Here it is, popped up on my second screen. And you can have a look here, make it a bit bigger for you, 15 and 20. As soon as it comes to contact, really sharp, and then there's virtually no zinc at all. So an example of a very sharp and hard contact. So one that could be built using traditional wireframing. So if I have a look at the footwall contact now quickly, similar thing. I've just mapped now the ore body here with the character tag and the footwall. Save and run the same thing. And have a look at that one. This time it pops up on the right screen, which is great. And again, you can see somewhat similar. Zinc grades between 15 and say 25. Come to the contact, bang, and virtually no zinc at all. So nice and sharp contact. Now, in contrast, if you have a look down here, you'll see that there's mostly this already is red. Then there's a yellow colour in this drill hole, and then there's red all the way through. A bit more yellow up there. So let's have a look at the relationship between this and this, the red and the yellow. So to do that, I've got a specification file that I've set up here. Similar process. Oops, must have selected the wrong one. Let's have a look at there. Character tag LMS. Okay, so we can change that here on the fly. And save that, run that. Does the analysis. And once again, Excel spreadsheet updates here. And here we have a different chart where the grades on either side are going between 5 and 30. And for me, that is really a continuous and shows very good continuity. So this boundary here, which is arbitrary at 0, grading away in each direction, is really no boundary. So what I would suggest is that this particular, these two units are the same. So whether that's the night shift geologist and the day shift, I don't know, or FIFO, and you've got different representations, but really that contact profile analyzer shows that that is the same unit. Okay, so how do we use that now in grade estimation? Just to wrap up the session, we first of all select the right menu, which is the grade estimation, go to estimation editor, and I want to use both WMS and LMS at the same without going back and changing my database. So I can do that. And the key thing here, I've got my estimation technique, my block model. When I come through to selecting my database, I want to select both of these units in the character tag there. And when I do soft boundaries, I turn that on. And in the details, when I'm estimating LMS up here, I also want to include those character values. And I can also give the use of those values a different radius. So I might have a fairly short radius, for example, just to keep them close to that contact and in the have a different bearing. So that's how you use the contact profile analyzer to identify a soft boundary, and then how to apply that when you do your grade estimation. So that's all I have in that quick little demonstration there. So I'll just jump back to the PowerPoint presentation, and whilst we're doing that, see if we've got any questions. Question answers for you. What license type do you require to access that new Swath plot tool that we've both demonstrated?
That's a good question, Steve. So basically, users need a geomodeler license or geostat modeler license to view it, and they should run with no problems.
Okay, fine. Second one here, that WMS function, I haven't seen many people use that at all, probably because it's buried deep into the menu system. Where do you get the links from there to get those WMS servers? How do you know what's available?
Well, the way I found that sort of data was it was available online. Most WMS data is open source, available to the public, and I just searched in Google for Australia data, and it came up. Depending on your region, you'll obviously have to specify which region you're looking at, and you should be all right to just copy and paste them into the panel, and you'll be good to go. Okay, fine. And a question for myself here is, on the decluster fields in the drill hole data, was it the weight of the decluster or the grade value? So what gets stored in the database, and maybe I can just quickly jump into the database here.
just to show that in ISIS, so ISIS here. Now I'll go to my database here and over here. Yes, so we have a declustering weight here on this one here. It writes the declustering estimation, the declustering weight as a weight field. You can also set that declustered weight when you do any charting in the Vulcan data analyzer as well. So here, you'll notice here, I'm using variable weighting and I'm using that declustered field to weight the zinc values. So hopefully that one answers the question for the customer there. So we'll just go back and just wrap up quickly. For those people on current software maintenance, you can download the latest version of Vulcan from users at maptek.com. And you will need Vulcan 12.02, as you've seen in this current slide, to use some of that functionality, especially the Swath plots. Now, of course, if you need any assistance with anything you've seen this afternoon, please contact Lance or myself or our general support numbers there. Now, if you'd like to view this webinar again, that will be available, as I said, in the coming days on Maptek.com video webinars. While you're still there, have a look at some of the other webinars we've recorded in the past. Got quite a lot of history there, and useful functionality. And we're also very interested in hearing from you to work out what webinars we should be putting together and putting up there for your enjoyment later. So one that we will have for Resource Geology in March is a webinar on Maptek's new machine learning for Resource Geology. That'll be the first ever webinar on that, and look out at maptek.com for dates and times for that. So thanks very much for everyone participating, and look forward to catching you at the next session.